There is a pump that runs 24 hours a day, 7 days a week, 365 days a year. It uses zero electricity, zero fuel, zero motors. It has almost no moving parts, requires virtually no maintenance, and once installed, it can operate for decades without a single repair. It was invented over 230 years ago, and most people alive today have never heard of it. It is called the hydraulic ram pump. And if you are wondering why something this useful is not in every hardware store, every off-grid catalog, every rural water system on the planet, that is exactly the right question to ask. Because the answer has nothing to do with engineering. The 1800s solved a problem that we are still paying monthly bills for, and the story of how that solution was quietly pushed aside tells you everything you need to know about who benefits when you stay dependent on the grid. The story begins in 1772 in England. A clockmaker and inventor named John Whitehurst built what he called a pulsation engine. It was a crude device, but the principle was brilliant. It used the natural force of flowing water to push a portion of that water to a higher elevation. No external power source, no combustion, just physics. The problem was that Whitehurst's design required a person to manually operate a valve. Someone had to stand there, opening and closing it by hand, over and over. It worked, but it was impractical for continuous use. The idea was sound. The execution was not ready. And so for 24 years, the pulsation engine remained a curiosity, a clever mechanism with no real future. Then, in 1796, a Frenchman cracked the code. His name was Joseph Michel Montgolfier, and if that name sounds familiar, it should. He and his brother Jacques Etienne were the same Montgolfier brothers who invented the hot air balloon 13 years earlier. Montgolfier was not a one-trick inventor. He understood pressure, fluid dynamics, and the behavior of gases and liquids under force. And what he did to Whitehurst's pulsation engine changed everything. He added a self-acting valve, a mechanism that opened and closed automatically, driven by the water itself. No human operator, no external input. The pump ran on its own, indefinitely. Montgolfier installed the first fully automatic hydraulic ram pump in his paper mill in Voiron, France, and it worked exactly as designed. Water flowed in from a nearby source, and the pump pushed a portion of it uphill to where it was needed. No electricity, no steam, no fuel of any kind, just gravity and flowing water. His friend and business associate Matthew Boulton, one of the most prominent industrialists in England, recognized the significance immediately. Boulton patented the design in Britain in 1797, and from there, the technology spread. By the 1840s, hydraulic ram pumps were operating across Europe and the United States. Throughout the entire 19th century, farms, villages, country estates, and rural communities across England, France, and America relied on this pump as their primary water supply. No connection to any grid, no fuel deliveries, no maintenance crews, just a device sitting quietly beside a stream, doing its job, year after year after year. To understand why this technology is so remarkable, you need to understand the physics that drives it. The hydraulic ram pump exploits a phenomenon called water hammer. If you have ever turned off a faucet quickly and heard a loud bang or a shutter run through the pipes, you have experienced water hammer. That bang is not just noise. It is a shock wave, a sudden spike in pressure caused by the abrupt stoppage of flowing water. In your plumbing, water hammer is a nuisance. In a hydraulic ram pump, it is the engine. Here is how it works. The pump is positioned on a flowing water source, a stream, a creek, a spring-fed channel. Water flows into the pump through a pipe called the drive pipe. As the water accelerates, it passes through a valve called the waste valve, which is held open by its own weight. The flowing water gradually builds enough force to push that valve shut, and the instant it slams closed, all that moving water comes to a dead stop. The kinetic energy of that water has to go somewhere, and it converts into a massive pressure spike inside the pipe. That pressure spike forces open a second valve, the delivery valve, and drives roughly 10% of the incoming water uphill through a delivery pipe. That water can travel over 100 feet in elevation, up into a storage tank, a cistern, or a holding reservoir. Once the pressure dissipates, the delivery valve closes. The waste valve drops open again under its own weight, and the cycle begins again. This happens 60 to 100 times per minute. No electronics, no timing mechanism, no controller. The water itself regulates the rhythm. The pump breathes in and out like a mechanical lung, powered by nothing but the flow of water and the pull of gravity. Efficiency ranges from 55 to 79%, depending on the configuration, the height of the waste valve, the length of the drive pipe, the elevation difference between the source and the delivery point. Researchers have validated these numbers through experimental analysis across multiple setups. A pump installed correctly, with good materials and proper sizing, can run for decades. Some units documented in the historical record operated for over 50 years without major intervention. So here's the question that should be nagging at you. If this technology works, and it does, demonstrably, with centuries of proof, why did it disappear? The hydraulic ram pump was never formally banned. No government passed a law saying you cannot use one. What happened to it was more effective than any ban. It was systematically replaced and then forgotten. In the late 1800s, coal-powered steam engines arrived and began reshaping industry. Then came diesel engines, then the electric grid. Each new technology offered speed, scale, and centralized control, and each one made the hydraulic ram pump look primitive by comparison. It was not that the ram pump stopped working. It was that the new systems came with something the ram pump could never offer: recurring revenue. Electric utility companies had zero incentive to promote a pump that needed no electricity. Pump manufacturers had zero incentive to sell a product that lasts forever and requires no replacement parts. Think about that for a moment. A device with no consumables, no wear components, no energy bills, and no service contracts is a commercial dead end. You sell it once, and the customer never comes back. That is not a business model. That is a one-time transaction, and industries are not built on one-time transactions. They are built on dependency, monthly bills, replacement parts, service calls, upgrades. The hydraulic ram pump could not support any of that. And so the market moved on, not because something better arrived, but because something more profitable arrived. This was not a conspiracy. No shadowy group met in a back room and decided to kill the ram pump. It was something more mundane and more powerful than that. It was an economic system that rewards recurring revenue over permanent solutions, that rewards dependency over self-sufficiency, that rewards complexity over simplicity. The ram pump lost not because it failed, but because it succeeded too well. And then came the regulatory kill shot. In the United States, water rights laws delivered the final blow. In most states, diverting water from a stream, even a stream that runs through your own property, requires permits, filings, and bureaucratic approval. In California, diverting water without a legally recognized water right is a finable trespass under the state water code. In Kansas, you need a state-issued permit for any water diversion beyond basic domestic use, and even that definition is narrow. These regulations were not written to target the hydraulic ram pump specifically. They did not need to be. They were written broadly enough to encompass any device that takes water from a natural flow. And a hydraulic ram pump, by definition, takes water from a natural flow. The result was that installing one, even on your own land, even using your own creek, meant navigating layers of permitting, compliance, and legal exposure that most people simply could not justify. The technology was not outlawed by name. It was made impractical through regulatory friction. And this pattern repeated across the developed world. Centralized infrastructure replaced decentralized self-sufficiency, and the building codes, water codes, and utility regulations were written to enforce that direction. The system was not designed to suppress the ram pump. The system was designed to promote the grid. The ram pump was simply collateral. But here is where the story turns. The hydraulic ram pump is coming back. The global market for hydraulic ram pumps was valued at $1.8 billion in 2025 and is projected to reach $3.2 billion by 2034, growing at 6.6% annually. That is not a niche hobby. That is a global industry in resurgence. The biggest adoption is happening in the places that need it most: Nepal, Uganda, Colombia, India, and across Southeast Asia. In communities where the electric grid does not exist, where diesel is too expensive to transport, and where clean water means the difference between life and death, the hydraulic ram pump is doing exactly what it did 200 years ago. It is moving water uphill with no power source other than gravity. In 2024, companies began integrating Internet of Things monitoring into ram pump installations, with wireless sensors that track flow rates, pressure cycles, and pump performance in real time, transmitted via satellite from remote mountain valleys and jungle hillsides. A 200-year-old technology monitored by 21st century satellites. And it is not just the developing world. In the United States, off-grid homesteaders in Appalachia are running hydraulic ram pumps right now, pulling water from creeks with as little as 6 to 13 feet of elevation drop and delivering it 65 feet or more uphill to cisterns and holding tanks. No permits from the power company, no monthly bills, no infrastructure beyond a pipe and a valve. And researchers are pushing the technology even further. Studies have demonstrated that the water hammer pressure surges inside a ram pump can be harnessed to generate electricity. By running the principle in reverse, using the pressure spikes to drive a turbine, engineers are developing micro-hydro systems that produce a few kilowatts of continuous power from nothing but flowing water. Enough to power a home. Essentially free. The same physics that Montgolfier harnessed in 1796 is now being used to create renewable energy systems that require no fuel, no grid connection, and no moving parts that wear out. The engineering community has not forgotten this pump either. Recent optimization studies have tested every variable: waste valve heights, supply head variations, drive pipe lengths, delivery pipe configurations, all to squeeze maximum performance from the original design. Numerical simulations now model the water hammer transients inside the pump with a precision that Montgolfier could never have imagined, mapping every pressure wave, every valve cycle, every energy transfer with computational accuracy. Integration studies have explored embedding hydraulic ram pumps inside municipal water distribution systems to recover energy that is currently wasted every time a pressure-reducing valve dumps excess head pressure. The energy is already there, in every water main in every city. It is being thrown away. The fundamental physics has not changed in 230 years. Gravity still pulls water downhill, water hammer still creates pressure spikes, and a device with no fuel requirements, no electrical input, no motor, and no complex maintenance schedule can still pump water uphill using nothing but the energy that nature provides for free. The hydraulic ram pump was not banned. It was buried under layers of regulation, under market incentives that reward dependency, under the cultural assumption that newer always means better. Every single month, millions of people pay electric bills to pump water that gravity could move for free. The technology exists. It has been proven for over 2 centuries. It is being deployed right now, today, across dozens of countries. And yet most people have never heard of it. The 1800s solved this problem. We chose to forget the solution. But the water is still flowing, the physics still works, and the pump is still waiting.